Right. So here, cis trans isomerase gas. So generally, you see the sigma to sigma transition, right? So they may occur in the forbidden region, right? So here you see in the 180 to 210 means it is what is it? IR, right? So near IR region. Generally, you sorry here, right? So UV visible range of radiation. So here it is in the forbidden region. So that's why only the pi to pi strong transitions are already here. Okay, and with this pi to pi star transitions, generally it may, right? So it may undergo the reactions with this in the triplet sensitization reaction, or you can see that particular, right, singlet state here. So generally this from here to here, you can see that ISC. Okay, so upon absorbing other transferring the triplets energy, right? Here you can see the reactions involvement of this olefins here, right? So you see here the cis stilbene. Okay, so why it is cis here? So two phenyls are in the same direction. So it is cis stilbene. Okay, so upon this irradiation with the photolight, right? Upon irradiation with the photolight at its respective wavelength, isn't it? So it is going to form the various products here, right? Cis stilbene and trans stilbene. So what is happening here? It undergoing the the isomerization. It is undergoing the isomerization. Means where this particular stilbene, right? So still again we are getting these products only, but it is undergoing some internal changes, internal rearrangement of the bonds here, right? The rearrangement of the bonds will be takes place, and we are getting the different products upon this isomerization, right? So yeah, the cis stilbene is giving the cis stilbene 93% and trans stilbene 7%, means which is this is the major product and it is a minor product. And in the same way, the trans stilbene also giving the same products here, right? So cis and trans both isomers are giving same products with a different ratio, with different ratios, like cis stilbene with the 93% of the yield and trans stilbene with the 7% of yield, where it is obtaining as a major product, it is obtaining as a minor product here, right? And how we are getting these products, right? How we are getting these products with the different isomers here, right? So with different isomers means the cis stilbene and trans stilbene both are giving the same products, like cis stilbene and trans stilbene with the unequal percentage here, right? So if you see the mechanism of these two stilbenes, then you can have the idea about that, how the products are obtaining and what is the pathway it takes place in that mechanism, right? You can see. Okay. So here, yeah. So generally, this is your stilbene with the orbital picture diagram here. Okay, and the yes, here the p orbital, which by overlapping of the the side to side overlapping of the p orbitals here. Okay, so upon here you can see first you irradiate with this photo light, then it requires what is that higher transition state, right? A higher transition state like singlet, other triplet, whatever, right? And that transition state upon further irradiation, it is undergoing that ISC, right? So upon this irradiation, we are getting this ISC state. ISC means intersystem crossing. Okay, so intersystem crossing. Then it is acquiring the triplet state here, right? So where generally the ISC, okay, ISC leads to triplet state here, okay. The irradiation of the ISC leads to the triplet state, means the transferring the triplet energy, okay, the triplet energy to the particular molecule here, okay. Now this molecule is, right, so is obtaining this triplet pi to pi star here, because only the pi to pi star transitions are takes place in this olefin here, right? Because there is no sigma to sigma star transition, because it is falls in the forbidden region. Okay, now, right, so after the triplet sensitization, transferring of the triplet energy, or we call it is that quenching, okay, quenching of the molecule here, quenching mechanism. Right. So upon the relaxation or the rotation about CC single bond. Now it is the CC single bond here. So you can rotate this, right? Carbon-carbon single bond. Rotation may be possible here because you cannot rotate the double bond here, and it is possible to rotate the single bond here, right? So upon rotation of this CC single bond, okay. So what happens here? Where the position of, okay, by holding this carbon here, you rotate this bond. Then what happens here, right? So the one side, right? The one side carbon, one side attached carbons, there the positions will be changes here, right? So here the phenyl comes here and the hydrogen goes there. So the position of these groups will be changed, right? So like that, where the configuration of this particular olefin is going to change here. Okay, means what is happening here? The rearrangement of the positions of the groups or the atoms takes place here. In this way, we are getting the different isomers here, right? Right now, okay, here with cis stilbene, and here this is your trans stilbene, right? Because it is the trans. Okay, here is a cis here. So both are, right? Both are acquiring the triplets energy state here. Okay, and upon a transition state, right? So this is your the transition state here. Triplets transition state, a triplets transition state here, where the rotation of, right, the rotation of this CC single bond takes place. Then upon the relaxation, we call the decay. Okay, relaxation or the deactivation, relaxation or the decay. So upon this, right, so this phenomenon, so we are getting, right, so we are getting these two products here, cis and trans products. This is a mechanism involved in this cis trans isomerization here. So here is some examples here. So where the isomerization reactions of this olefin, right, at various what is that wavelengths here. All these examples you can go through this. Yeah, next is a acyclic addition to alkenes. Acyclic addition. So it's also where this the addition reaction. So generally here the addition reacts in this addition reaction. So here you see this is your what is that? So cyclohexene. Okay, methyl cyclohexene here. Methyl cyclohexene. Upon reacting with this methanol, right, in the orthoxylene solvent. Orthoxylene is a solvent here. Okay, so it is going to form this what is that? Yeah, 1-methoxy methyl 1-methoxy, 1-methyl cyclohexane, and this particular olefin, right? This alkene is forming here. So how these products are obtaining, you can see. Okay. So here this methyl cyclohexene, right? So upon sensitization, right? The sensitization means here, right? So where this singlet to triplet stage, right? So whose ISC, okay, ISC efficacy is here is a less than, okay, less than 5 here, right? So whose efficacy is less than 5. So then where this sensitization, upon sensitization, where the energy transfer is takes place here, triplet energy, right? The triplet energy transfer is takes place, right? This is ISC here. So now this ISC is transferred to the molecule, right? So to this molecule here, okay. So here your this particular, right? So cyclohexene, methyl cyclohexene is going to convert into triplet sensitization molecule here. Then okay. So here protonation, okay. The protonation is takes place where this bond comes out here, and it is reacting with this in the methyl CSCO minus and the H plus. Okay, so this bond is going to react with this proton here, right? Then here you will get positive charge on this carbon. Okay, so here you will get the positive charge here. You see here. Now, after getting this carbocation, okay, carbocation. So there are two reactions takes place, right? One is the addition reaction. And either addition reaction or the elimination reaction takes place. So upon addition of this methanol, methyl cyclohexane, and upon abstracting, right? Here is a CS2. Okay, hydrogen is there. So this may be shifts here. Then we are, so like that. The rearrangement. What is happening here? The rearrangement of these groups or the atoms takes place. Here also same thing. Okay. So where this cycle rearrange of their here also same thing where upon to shift of this one. So where this by abstraction of this proton are getting this where abstraction. So like this, we are getting the various products by using this bicyclic derivative. Here also same thing. Now the photochemistry of conjugated dienes very, very important, right? So conjugated dienes very, very important. Right? So generally, okay. So in the previous classes we discussed that the dienes, okay, butadiene for example, right? Butadiene. So it's ISC, right? Efficacy, ISC efficiency 0. Okay? It's ISC efficiency 0 here because the energy gap, right? The energy gap here, S1 to T1 energy gap is how much it is? The difference, okay? The difference here 124 here, and here is a 60, right? So the minus, if when you subtract is 64 kilocalories. So this much energy gap is there, difference is there. So its energy gap is more. So its ISC efficiency, efficacy, or the ISC efficiency is less, or the negligible generally. its ISC efficiency is a negligible ISC efficiency. Why it is negligible? I told you that because the energy gap between the singlet singlet transition state to the triplet transition chain. The energy gap between these two is high because it is 124 minus 60 here kilocalories. Okay, per mole. So it is 64 kilocalorie. That's why it is having negligible ISC efficiency. So, so here the direct irradiation of this particular dienes, right? It leads to this singlet, right? So singlet pi to pi star transitions here. And upon sensitization, triplet sensitization, it is going to acquire this pi to pi star transition triplet state here. Okay, so like butadiene here, right? So when this benzophenone is taken, okay, benzophenone and butadiene, now it transfers its ISC. Okay, so it transfers its triplet energy to this butadiene. Then this butadiene is triplet state. So like that. Right? So here the butadiene is it is gaining the energy from the triplet sensitization here, right? Triplet sensitization, and it is giving that various products, right? Okay, you see this the reactions. Right? Here the butadiene you see. Okay, so upon the isomerization, this butadiene upon isomerization, this is also same butadiene. Right? So, and upon the photochemical reactions, it is going to form the various products here, like cyclobutene and bicyclobutane, right? And here the diolefin here, right? And vinyl bicyclohexane and cycloocta 1,5 diene. So all these are the products. All these are the products are possible with this particular butadiene reactor. Okay, you can see, right? So here, yeah. Right. So here the S is on so the transition state here and transition state. Simply here the radical and its radical is combined and it forms this cyclobutene. Okay, and if it is right, so if this particular number of this protein is involving in the reaction, right? Here is a yes cis conformer. Here this is yes trans conformer. Okay, so when this yes trans conformer is involving in the reaction, when this bond, okay, when these two bonds undergo homolytic cleavage, then this radical, okay, this radical here, whatever. So it is combining and it forms this double bond. And the terminal, right? The terminal double bonds, right? So terminal double bonds, it may undergoes the cross linkage, right? So here, this is, right? It is combined here and it is combined. So we are getting this product. So like that, right? So the various possibilities are how we are getting this, this particular, right? 2-vinyl bicyclohexane. How we are getting here? By the dimerization. Okay, all these are the dimer products here, right? Upon dimerization, we are getting this. And here also same thing when upon the direct irradiation, where these two bonds are going the okay, this homolytic clear. So these radicals combine and it forms double bond. These radicals, okay, here these radicals and it forms this bicyclic compound. Right? So here all these are products related. And here this triplet sensitization, right? So this is okay. These products are okay. So all these products are right. All these products are singlet, right? So singlet upon the singlet involvement of the pi to pi star, okay, singlet, right? Singlet state. So these are the products: cyclobutane, cyclobutane. And these are the dimeric products here. But when they means cyclobutane, right? Cyclobutadiene are under triplet sensitization reaction, right? So the products are different, right? The products are different here upon triplet sensitization. So the cyclobutane, trans 1, 2 divinyl cyclobutane, and 4-vinyl cyclohexene. Sorry. So where the singlet, upon singlet here, cyclobutane, okay, cyclobutene here, right? So but triplet, we are getting these products. So with triplet sensitization and okay, triplet excited state and singlet excited state, we are getting the various different products of involvement of your butadiene here. This yeah, various sensitizers, okay, various sensitizers, and what is it? The energy, triplet energy transfer from that sensitizer to your butadiene, and the respective product formation here, right? Respective product formation, the percentage of product here, right? So it is very a complete picture of this products formation of with the sensitizers here. If it is what is that, estophenone, right? Because carbonyl compounds, right? Carbonyl compounds are the good. Okay, carbonyl compounds are whose ISC is good. Okay, ISC, good ISC here, ISC values. That's why. So here the various carbonyl compounds had their contribution of the triplet sensitization energies here. You see, if it is estophenone, its triplet energy is 3.6 kilocalorie per mole here. Okay, and the products, right? The product, okay. So product, right? So 1,2 divinyl cyclobutane. So how the formation of this percentage, you see, it's from benzoyl, the benzoyl, the triplet is how much it is, 1.9, and product obtaining with the ratio or the product obtaining percentages, it is 16% of cis conformer, and it's 80% of the trans conformer, and 4% of the dimer, right? And benzophenone, right? So benzophenone, it's what is that, ISC, right? The ISC triplet energy is 68.5, and the percentage of product obtaining is 18% of cis and 80% of trans here, and only 2% less percentage of dimerization. Okay, and various, these are the some other carbonyl compounds and their contribution here of triplet energy here, right? Yes. Here you see. Right. So here you see this butadiene. This is the butadiene. Okay, with whose what is it? The triplet energy is less than, right? The triplet energy is more than 60 kilocalorie. The triplet is more than 60 kilocalorie. So the products is formation is these dimeric products and the of usual compound products, right? The usual products and some rearranged products and dimeric products here. Right? Yes. Next, the one more important olefin rearrangement reaction is the dipymethane rearrangement reaction. Means in the dienes, right? The involvement of the dienes, right? So this is dipymethane rearrangement. So this is also called as a Zimmermann rearrangement reaction. Okay? Zimmermann. This is also called. Okay. So Zimmermann. Zimmermann rearrangement. Okay. Zimmermann rearrangement reaction. The another name for this one is a dipymethane rearrangement reaction. Is a Zimmermann rearrangement. Very, very important here. Right? Very, very important. You can keep 10 or 20 stars here. Okay. It's very, very important. Zimmermann rearrangement is very, very important. So what is Zimmermann rearrangement? Or the dipymethane rearrangement. Okay, dipymethane rearrangement or the Zimmermann rearrangement. So what is that? The photochemical rearrangement of, right? The definition, the photochemical rearrangement of the 1,4 dienes into cyclopropane derivative. Very easy and simple. Okay, and very, very important here. Right? The photochemical rearrangement of 1,4 dienes into cyclopropane derivatives is called the dipymethane rearrangement or Zimmermann rearrangement reaction. Okay. So generally the products may be, right? Here the products may be the cyclopropyl derivatives here. And generally the starting materials are the 1,4 dienes. It may be cyclic or acyclic, whatever. Any compound you can take. Right? Here you see the example of the 1,4 pentadiene here. Okay. 1, 2, 3, 4, and 5. 1,4 pentadiene here. So upon H2, the direct irradiation. So the products are the vinyl cyclopropane, right? Here is a vinyl. This part is the vinyl here. And this is your cyclopropane. Okay, cyclopropane. So these are the products. So the dienes, okay, 1,4 dienes giving the vinyl other cyclopropane derivatives, right? And you see the beautiful mechanism of this Zimmermann rearrangement or the dipymethane rearrangement reaction. How this particular rearrangement takes place. Okay, so like every reaction, it may absorb the right the photo light here, and it undergoes the excitation, like singlet higher excitations, right? The higher excitation, S02, S1 here. Okay, so here is a excited singlet state here. Okay, pi to pi star transition. pi to pi star transition, singlet transition here. Yeah, so at pi to pi star singlet transition state, it is going to, okay, this bond is undergoing the homolytic cleavage here, and it is going to form the radical. Okay, and this is also undergoing, both are undergoing the homolytic cleavage. So here it leads to formation of these four radicals here. Here radical, here radical, here radical, and here radical. And these two radicals combine and forms this cyclopropyl derivative. Right? These two radical forms combine together and forms a C2C4 bond formation. You can see, right? Here is a C2C4 bond formation here. Then it leads to formation of this cyclopropyl ring. Okay. So after formation of this cyclopropyl ring, okay, so where the two, okay, C2C3 bond, okay, C2C3 bond formation, like yeah, C2C1 bond actually, C2C1 bonds, right? Where the C2C3 bond cleavage, C2C3 bond cleavage takes place. Later, the C1, C2 bond formation will be takes place here, right? C1, C2, C1, C2 here, C1 bond formation is taking place, right? Now the left out radicals are C3 and C5. Okay, so now this C3 and C5 bond combination, combination of this C5 and C3. Now the C3 C5 bond formation is takes place. This 1,5 biradical or the diradical. Okay, so it is going to form as a cyclopropyl ring. So upon inversion, right, you will get this product. Upon inversion, you can write like this. Okay, so like that, we are getting this cyclopropyl, right, vinyl cyclopropyl derivative. So this is called the dipi. Okay, dipi. Di means two pi bonds. Dipi methane rearrangement reaction here. Okay, and you can see various examples and very, very important here. Right, so here is a allyl benzene. Right, here the pi diene. Okay, so here the 1,4 diene, it may be cyclic or the acyclic here. So here the partial cyclic 1,4 diene, right? So partial or the partly cyclic 1,4 dienes. So it undergoes this rearrangement here, right? So here you see this is 1, 2, 3, 4, 5. So this bond and this bond undergoing the cleavage here, and we are getting this phenyl cyclopropane here. And how it is takes place here, how the mechanism, you can see mechanism here, you see this bond cleavage, and here the bond formation, again this bond cleavage here. Okay, and now this bond 1,2 bond formation, then benzene formation takes place, and this formation. So you can see very simple. Okay, phenyl cyclopropane is the product here. And yeah, beta gamma unsaturated carbonyl compounds also undergoes this kind of dipi methane rearrangement, but generally it is called the oxa dipi methane rearrangement reaction. Here also you can find the diene here, right? Here also you can find the diene, but here the oxygen also involving in this rearrangement reaction. That's why you call it is a oxa dipi methane rearrangement reaction. So in whatever the product is there, whatever the starting material is there, the products are the cyclopropyl derivatives only. Cyclopropyl derivatives only. So you see this. What is the product here? So upon this carbonyl compound, we are getting this acyl cyclopropane. Okay, this is the acyl cyclopropyl here. And here also, So where this diene 1 comma 4, okay, diene here. So it is giving this product cyclopropyl olefin in here also. Okay, same products are and same here also same thing here the diene. Only thing is you have to find the diene. You have to find the diene whether it is a part of the ring system or a cyclic system. Cyclic system or the acyclic system here. First you find the 1 comma 4 diene. It must be 1 comma 4 diene here. Okay. So you see that the diene is at 1 comma 4 position. No other dienes are accepted for this rearrangement here. Right. And yeah, here also same products. And yes, all these things. And one more example here, right? Somewhat technical, right? So in this 5 comma 5 diphenyl cyclohexa 1 comma 3 diene, right? So here you see, are you able to find this diene here? So generally it is not okay. You cannot find here. So you see, here is right. Here is a diene. It should be okay. It should be at 1 comma 4 position. So if you give 1, 2, 3, so 1 comma 3. So this is not valid here, right? This is not valid. So you expand this. You expand this benzene. Okay, you expand this benzene here. Then 1, 2, 3, 4, 5. So it is 1 comma 4 here, right? Here because here 1, 2, 3, and 4. So this is not the valid 1 comma 4 diene here. So you can expand this. 2 phenyl groups are there, no? So you expand this. One of the pH is written like this here. Then now it becomes 1, 2, 3, 4, 5. So get 1 and 4 diene. Now it undergoes the Zimmermann rearrangement, and we are getting this product here, bicyclic, the phenyl derivative. Okay, so here also same. So the various products here. And intermolecular cross-addition reactions. Right? Cross-addition reactions means where this the olefin undergoes the homolytic cleavage. Further, where the the terminal, right? The terminal radicals are with inversion, right? Of the spin, they are going to combine other adding here. So that is so this the into the reaction is this is the realization reaction. Okay, here is the tradition. photochemistry of engineering. So here the ring isomerization of benzene here, and the products obtaining in the ring isomerization of benzene is these are the products here. Okay, here's a okay. So here is a benzene, and when it is irradiated at different wavelength here, right? So generally, when this irradiate, okay, yeah. So when this irradiated to wow, what is that? 120. How much it is? Yeah, 162 to 200 nanometer. Okay, 162 200 nanometer. So where it is giving these products here, valvalin, fulvin, and dibarbenzene here. And when it is irradiated at 254 nanometer, it is giving valvalin and fulvin here. Okay, valvalin and fulvin. So the products, right? The different products are obtaining at the various wavelengths of the it is going to absorb the 254 nanometer radiation here, right? Then, yeah, so all bonds are, these two bonds are going to homolytic cleavage, right? And where this bond and this bond forms this cyclic profile derivative. And after that, these radicals combine and it forms this particular compound and leads to formation of the valvalin. Okay. And it okay. And means here the various possibilities either. Okay. So by coupling of these radicals here, so it is going to form valvalin. Or okay. So here by cleavage of this bond here. Okay. So it is going to form this particular uh, olefin derivative, right? Olefin derivative. Generally, it is called fulvin here. Or one more possibility means at low radiation, 162 200 nanometer here. So where this rearrangement, what is happening here? The rearrangement of the electrons, pi electrons, rearrangement of the pi electron is taking place, and it leads to formation of divar benzene here. Okay, so like that, benzene is going to form, give the various photo dimer, sorry, photo isomerization of benzene, right? The photo isomerization of benzene. Uh, Photo isomerization of benzene of orthoxylene. This orthoxylene, right? So it is going to form metaxylene. So what is happening here? Where the position of methyl group is changing here. So it is undergoing the isomerization. And how this isomerization is takes place? Very simple here, where this bond, right? This bond electron is undergoing this homolytic cleavage and the rearrangement of this. Okay, combining of this bond electron, this bond. So it is going this valvalin derivative, and upon the fission of this C1 to C2 and C3 and C4 again. Okay, so it is further again it undergoes this homolytic cleavage and the recombination of this bond and this bond. So going to form this one, and upon the okay, right. So upon flipping of this bonds, we are getting this metal jelly. So like that, is if R equal to yeah, okay. I'm stopping here. This paper 5. Now I will send you the link for paper 6, paper right, paper 8. So just you go through that link. Okay, I'm stopping here. This paper 5. Next session is for paper 8 here. I will send you the link in your Telegram.